In this lecture, we cover all aspects of drone (UAV) design, from planning, component selection, fabrication, and flying. Unmanned aerial vehicles, or UAVs, can be piloted by somebody on the ground or pre-programmed to follow a route or perform a specific task. A UAV can come in all shapes and sizes. In this lecture, we specifically focus on multi-rotors. Multi-rotors are categorized by the number of propellers. This drone design focused on in the course is a quadcopter, or UAV with 4 propellers. A UAV can have any number and orientation. We focus on quad, hex, and octocopters and their applications. Quadcopters range in size from nano, that can be the size of your finger, to units that are several feet across. Their intended application dictates the size to a certain extent. Smaller drones are used for indoor hobby flight, while larger ones have specific functions. Somewhere in the middle, there are a large range of sizes that are used for various reasons, from FPV, or first-person view quadcopter racing drones, to GPS camera tracking drones, and the newly popular backpack drones. Quads are probably the most popular style out there, and you've likely seen or flown one of these already. Going a step further, hex and octocopters, you add the ability to carry more weight and have a bit of redundancy in case of a motor failure. If a motor fails on a quadcopter, gravity wins. On a hex or an octocopter, you can still fly and land safely in most cases, protecting whatever precious cargo is being transported. This could be a burrito or life-saving medical supplies. By far, the biggest application, other than just hobby flying, is in aerial photography. This could be a selfie drone or a rescue drone like the one we're creating. Camera drones are being used for 3D mapping, construction, search and rescue, action sports, agriculture, military, security, and even real estate. Basically any reason you would need an eye in the sky. Cameras can be anything from an octocopter carrying a DSLR camera to a quadcopter carrying a thermal imaging camera. Design and construction teams are quickly discovering the value that drone mapping brings to all stages of a construction project, including initial site survey and design, volume and elevation measurements, comparisons, and quality assurance. In a fraction of the time it takes to conduct a ground-based survey, a drone can automatically fly and capture imagery of a project site that can then be processed into highly accurate point clouds compatible with Building Information Modeling, or BIM software. Industrial designer and visual artist Eli Delia has taken drone design to the extreme level with Game of Drones. The drone sports company is creating a worldwide platform for beginners and experts alike to compete in drone competitions and sports leagues through groundbreaking drone hardware, software, and the toughest drone airframe. Eli is on the forefront of drone design, developing the next generation of UAVs for aerial combat to industrial and agriculture use, and even search and rescue training operations. Oftentimes, technology is driven by innovative students at colleges and universities, and design projects or challenges can be a breeding ground for innovation. This such innovation environment is exactly where the inspiration for our course came from. Japanese duo Yuki Akasawara and Ryo Komedo, aka Team ROK, and their innovative X-Vane design was born out of tragedy. In the wake of natural disasters in Japan, Yuki set out to create a style of post-disaster search drone. His innovative approach to design inspired us to see where we could take it next. In addition to Yuki and his design project, universities around the world are paying close attention to drones and utilizing them throughout their curriculum. One such university is Virginia Tech. Virginia Tech has invested in an outdoor drone cage that allows students and faculty to explore the next generation of drones without worrying about the confines of FAA safety regulations. This drone playground is 300 feet by 120 feet and 80 feet tall. This means things like swarms of drones working together can be realized without the risks associated with testing these drones in the open world. There's almost an endless line of stories of innovative students realizing new and unique ways to utilize this technology. And the great news is that it's literally at the fingertips of everyone. The last thing that we need to mention before we start designing has to do with legality. If you plan on actually building and flying your own drone, it's important to check with your local regulations. Best bet is to check your local regulations and the FAA website.